Welcome back to Jupyter Notebooks Part 2. I'm going to show you as fast as I can how to make a graph in Jupyter Notebooks. All right, let's do a code block. So in order to get a graph, you need the graphing libraries. So you need to import libraries. I'm going to go to this document that I made before and just copy and paste the import commands. Control-C, Control-V. You can copy and paste mine. Haha. Okay, so what I've done here is import command math libraries and plotting libraries. How do I know that's working? Just type in pi, and if you get a value for pi, you know you got your math libraries in there. Haha. So it looks like it's working. This would not work unless I hit this first, right? So you have to click in order all of the buttons, all the commands. Let's do a code block. Okay, so plotting a library or making a plot. It's called PLT plot. That's the function, and the way it works is you plot x versus y, okay? So if I hit play, I get an error message because I haven't defined. Oh, it actually doesn't. That's funny because it should have, let me just do x2, y2. Normally what would happen, I actually have defined some x's in this Jupyter Notebooks. So x2 is not defined, right? Like, doesn't know what x2 is, y2 is. So what we're going to do is, this is what you would see if you just type in x and y, but I actually do have x's and y's defined in there already. So if you type in x right now, you can see that I have something in there already defined. But let's define x2. Let's just do one data point real quick. x2 and y2, let's just plot one data point. Look, 1, 4. So I'm plotting this ordered pair 1, 4. Let me move this up so you can kind of see what's happening here. So I move this up. So x2 and y2 equals 1, 4. So if I PLT plot x2 and y2, I get 1, 4. You can't actually see it. It should be right here. It's like a little, I don't know why it doesn't plot some sort of marker for it. But what this command will do is make x marks the spot right there. So it's plotting x's for 1, 4. So what this is called marker style. And so you can actually change these if you Google marker style. Like you can make plus signs instead of x's. If I hit a plus sign right there, it'll make a little plus. Okay, let's go back to x because I like x the best. Okay, so you can change the color of these things and everything as well. Okay, so here's a basic plot. That's great. How do I make like more than one? How do I add more pairs? So the way you can do this is you put it in brackets like this, and then you put commas between your data points. So 1, 4 is the first one. The next one, the next ordered pair might be like 2, 8, right? So if I hit play on that and then hit there, now I have 2 data points, right? 1, 4 and 2, 8. It's kind of separated them out. And you can just keep doing this, right? For however many, you want 12, 16. I'm just making up data here. Okay, and then when you plot it, all done. So look, I've been talking for just a few minutes and we have a graph. High five. Hey, really quick, I'm just really picky about this because I'm science. How do I write like the labels? So I'm just going to write labels on the axes. So it's plt.x label for the x one. So see how it pops up right there? I haven't even typed it in all the way, but there it is. And it's a function. So functions have parentheses always. So like it's like saying cosine, right? You can't just type in cosine of 30. The computer doesn't know what you're doing. So you have to put in parentheses because it's a function. Cosine's a function. So cos of 30, and it's going to give you some value. This is in radian mode, not degree mode. You can tell if you're smart because you should probably have cosine 30 memorized, right? Or what's sine of 30, right? Sine's the one everyone knows, right? Anyway, whatever. Okay, so X label, I don't want to go off on tangents here. And then when you're typing in text, you usually do like quotes. So here, this might be mass in kilograms, right? So mass in kilogram appeared on the X label, just like that. How do I do the Y label? Y label. And again, you're going to type in quotes, I don't centimeters, something like that. Got to put your units in. So that is an example. You can copy and paste this if you want. I'll put this Jupyter notebook in the YouTube comments, so you can just look at it and copy it later if you want. So this might look real complicated and hairy, but it's actually makes sense. You're plotting an x versus a y. You're making them little x's, and you're putting some labels on. And this is really all I expect in my homework assignment, because most of graphs, you know, like we capitalize mass, right? Like I'm kind of like picky about like this kind of stuff. When you're making graphs, you just want to know what you're plotting, and you kind of have to know this kind of thing. I don't like blue. Let's make it black. So the command to make it black, I think it's actually like there's two ways to do it. Let me. I know this is taking extra time, but I think you do black like that, and there you go. Oh, it's connecting the dots. So you know what maybe the shortcut way for this is KX. If you type in a KX, it won't connect the dots, and it'll make it nice. So just remember this, K in front of the X is going to put X's. There's like all kinds of help. If you just Google PLT plot help menu, there's a million different, like, see how it's connecting the dots now? That's what that command, that little space thing does, or the hyphen thing does. So like, I like them like this. But yeah, I actually have pulled up the, let me go back a little bit here. So if you just type in help plt.plot into Google, the first thing that comes up is matplot.pyplot plot documentation website. If I click on this, and you scroll through here, there's so many different graphs that you can make. Because just like in, you know, science class, right? Like it's going to show you all of these things, right? So here's the X marker, right? Here's the solid line style thing we just typed in. Here's the black color, right? So all of these things are in here. And then if that's too hard for you to understand, which it was for me, like I don't usually go through here and try to pick out these things with the table. I usually just look at examples. So if I want to make a graph, I can come down here and it will show me some examples, right? Like let's say I want to make mass scatter, you know, like something that looks like that. That looks cool. And so again, it's going to show you commands down here you can cut and paste, and then like figure out how to make these graphs. Okay. So anyway, the help menus are online, but I basically have showed you how to make a graph, right? Your first graph ever. That's great. So most of the time, I already have my X and Y data. So your assignment is to go online to Kaggle.com. Kaggle is a free machine learning data set place where you can, like, you know, it's nice because they have a lot of data sets on here, and you can just find whichever one you're interested in and make a graph. You're going to make a scatter graph. So I'll just do an example for you, like how to do this. So World Happiness Report, right? Like, I mean, so these are kind of cool. You can go through, there's biology, social science, they're in categories, right? World population by year, right? Is the world population going up? You know, that actually is kind of interesting. Let's try that one. So if I click on it, you notice that like, it tells you basically what Kaggle's nice because it always gives you a CSV file. Pretty much always what you're looking for is a CSV file. So if I click on this thing, it'll probably download, I'm hoping. Watch it, just OI and Peter, hit download here. Okay, so download it. You have to be logged into your Google to do this. You have to, and I guess I can now download it. So if I click on this. So the first time you go into Kaggle, I believe it like asks you like to log into Google and if you're okay with this kind of stuff. So when I download it, it looks like it downloaded a zip file. But if I double click on this, Microsoft Excel is usually the thing that opens up. So if you have Excel or some other spreadsheet program, it'll open it up. And you can see here the data set. So here's the year, and then there's the world population. And it has some other things like change, density, urban, you know, like percentage, urban percentage, that kind of thing. So interesting data set. I want to make a graph of population by year, okay? And so there's probably like 100 data points or something, 70 data points, right? That's great. And you can do this in Excel, but I want to do it in Jupyter. So high five. How do I do this in Jupyter? So let me save this actually. I'm going to save this to my local computer. Save as, put it on my desktop. I'll just call it world population instead of copy of world population. I don't know why it's called copy of. Anyway, there we go. Save. I'm just gonna let's minimize this. I don't like closing windows till I'm done. But so now I'm gonna go to my GitHub repository, and again, a little bit of like background here. So you have to store the data somewhere on the cloud, and I'll put a link to how to create a GitHub. GitHub is a free. So this is like a free. It's like creating a Google account. Google accounts are free. You just have to create an account. It takes like a couple minutes. You have to put in some emails and confirm that you're actually a person and that kind of thing. And then, so my username is FearLab, and I created a folder, or they actually call them repositories, called datasets. So datasets, that's where I store all my data. It's just a folder in my username. It's kind of like creating a Google Drive. You'll have like a folder that you have to put everything in. So the way you put stuff in is you add file, upload file, and then you choose your file. So I'm going to choose the world population, high five, and commit changes. You have to hit commit changes to have it absolutely work. So processing. So now if you scroll down to the bottom here, there it is, world population. If I click on it, it shows me what the data set looks like. High five. And what you want to do is you go to the raw data set. So see where it says raw, click on that. So this is what the CSV, by the way, CSV stands for something, comma separated value. So these are values separated by commas, right? Comma separated value. So anyway, this is the link you want. That's the link you want. Right click on that, copy that, and you're going to paste that into your import menu. So let's do a new code block here. I know we haven't talked a lot about this, but basically you're going to do this function called, it's going to be like data equals pd dot read CSV file. You can do it like, looks like you can do Excel files and that kind of thing too. So that's the command you want. Let me hit play. I went through this pretty fast because I'm trying to go fast, but this is a pandas file, which means you have to have imported the pandas directory, which we did up here, right? We imported pandas. It's one of the math. So this is a function here that reads in CSVs. Its job is to just take any CSV, comma separated value thing online. So the input is just the raw data file. You have to put in the raw data file. This can be problematic because a lot of people, when they first do this, they make a GitHub and they type in, they copy and paste this, but this isn't a raw data file. This is like, so you want the raw data file. Okay, so when you go, so it's imported the data. Let me just show you by, well, let me do a new code block here. New code block. If I type in data, let's see what happens. We have, see what happens. We get like, so data was not defined before I typed this in, right? So now I have all the data on there. See how it's got like year and population and this kind of stuff? It's got all of it. So how do I make a plot of X versus Y? Well, which ones are my X's? Year, right? Years are my X's and populations are my Y's. So I'm gonna do a new code block here. And let's just do a quick timeout here. So let's do, how would I get all the years? So the way you do this is you have to call, it's the first column of data, right? So X equals data, and I believe you have to type in parentheses because the data is, well, a bunch of things in it, and then you put in the brackets and it's year. Let me see if that plays good. See how I screwed up. What did I, is it not called year? What's it, did I do this wrong? Data frame not available. So I'm gonna cheat and look at like my code because I think I just screwed up the parentheses or whatever. Import a load of data set, plotting data. It's data, there's no parentheses in data. So yeah, I was trying to remember if data, I was like, what, do we put parentheses in? It's not a function. I'm like, data's not a function. It's just a bunch of numbers. So that will fix it. So just really quick, just to make sure that the x's are all good. See how the x's are just years? Awesome. Let's do a code block for the y's. So y is just going to be the second column, which has a name, right? Population, right? Population. I know I'm doing it right if it's giving me some numbers here. So there's the populations. So now we make a graph of it. How do we make a graph? plt.plot, and then our x versus our y's. Let's make them black x's. And then we can put in some labels in a second. Let's just make sure it works. There's the world population over time. That's an awesome graph. That's probably a very famous graph that we've already made. What's our label? Year? I just hit the enter button when it's hovering and it automatically types in the rest. Population. There we go. So that is a example of a cool graph that we can see. You can see that it's going up and up and up. Anyways, so this must be billions of people over here. 1 times 10 to the 9th is billion, and then this is yours. So what have I done here? I had to import data from a CSV file, and the real trick of this is to make you have to create, so if I collect data in like the lab, on a lab acquisition tool like a Veneer LabQuest or something, I can get a bunch of I can get a CSV from that. I can save it, or if I use like Logger Pro or something. But I'm going to have to upload that data set online somewhere. This actually is kind of hard to do if you put it on a Google Drive. So like if you put it on a Google Drive, there is a way to do it, but it's not as easy if you just put it into GitHub. So make a GitHub repository. That takes like 5 minutes. I'll put a little link to a video that shows you how to do that in like 3 minutes or whatever. But and then you know, just upload your repository there, and you have to kind of, the trick is you got to find the URL to the raw file, because the raw file will look like you know, it'll look like this, just commas. Everything's commas, right? That's what you want. Helpful hints: if you have stuff at the top that is not your titles, get rid of it, like delete it. Like so if my Excel spreadsheet, usually an Excel spreadsheet, like if you look at it, it usually has information up here, right? Like, you know, people's names who wrote the thing, their class period, you know, and like just delete all that stuff, because you're only interested in the data, right? So sometimes you can have stuff up here that is going to kind of screw up your import. So one quick trick is just like take all the stuff that's not data. You can have 1 line. I like to leave 1 line of headings, and then just delete all that in your Microsoft Excel or spreadsheet program. It could be like, I forget what the Mac one, Numbers or whatever you use in Mac land. And then, so now you have this, and just upload that thing to GitHub. And that's a helpful hint. So you end up getting just commas and numbers and 1 row of titles, right? Okay, so what's my assignment? My assignment's to go on to Kaggle, find a cool data set, and you're going to write some explanations as to what you graphed, right? This one's real nice because it's, you know, everybody is interested in how, well, not everybody, but this is a cool graph because you can see that it's not just a linear growth here. It's like going more and more, it looks like. Anyway, so, and there's other things you could graph with this data, right? Like you could graph urban percentage versus year and that kind of thing. So there's quite a bit of data analysis you could do here. But this was a quick tutorial in how to do graphing in Jupyter Notebooks.